go and let's solve log equations. All right, so first of all, I want you to notice that there is a typo on this sheet. So I wrote that on the solutions and I talked about it in class, but make sure that you fix the typo. Otherwise, your solution will be imaginary, and that would be bad. So, all right, let's get back to start on this equation. This is probably the easiest type of log equation you can get. Because it says equal here, and there's just one log on either side, there's no other numbers, and the bases are the same. So since we have all of those beautiful things happening at once, all we have to do is set these two guys equal to each other. All right, and so once we do that, we can solve for x. So let's first subtract 3x from both sides. Oh, this is nice, right? And that is going to give us 4x squared equals 1. Oh, this is so nice. So now we're just going to divide both sides by 4. I love it when we don't have to factor a quadratic. And x squared equals 1/4. Now we are going to take the square root of both sides. But don't forget, when you take the square root of both sides, oh my goodness, so many times we forget the plus or minus. Please do not forget that. So x equals, now over here I'm going to show you, if you take the square root of 1/4, the square, you can write it, you can break it up like this, and the square root of 1 is 1, and the square root of 4 is 2. So that's what I'm going to do over here. I'm going to have plus or minus the square root of 1/4, which is 1/2. Boom. And you can plug those back into x and check your work. This log equation is a little tougher just because we have to use a log property. And you need to be careful with using log properties because you don't want to forget the log. So since the bases are the same, they're both 2, we can actually use the quotient property and write x squared plus 6 over 5, and that equals 1. Now once you get here, you have to solve this log equation. Remember, logs and exponents are inverses of each other. So to solve this log equation, we're going to take the inverse. We're going to undo it by using exponents. So with our exponent, what we're going to do is this is the base to a number, right? So that means base 2 to the 1 equals the number, which is x squared plus 6 over 5. Then we can just multiply 5 by both sides. And we have 10 equals x squared plus 6. We can subtract 6 from both sides. 4 equals x squared. Oh, this is a lovely one. Take the square root of both sides, and don't forget, never ever forget your plus or minus. So x equals plus or minus 2. Last but not least, now this one's even a little trickier because unlike the first one, we had log equals log. This time we have this little 3 here, okay? So that means we can't let 9x equal x because there's a 3 here. So we have to do something else, and that something else is a log property. So in order to use log properties, the logs have to be on the same side. So we're going to go log base 3 of 9x. We're going to add log base 3 of x to both sides plus log base 3 of x, and that equals 3. Now that they're on the same side, right, and they're together, and they have the same base, we can use a log property. So we are going to use the product property. So that means if these are added, remember when you add when you multiply exponents or like bases, you add the exponents. So here we're going to write log base 3 of 9x times x equals 3. So once we do that, that gives us log base 3 of 9x squared equals 3. And again, to solve a log equation, we have to write it as an exponent. So we have, there's the base, there's the exponent, because the log is the exponent, right? So let's write that down. We have 3 to the 3 equals 9x squared. I'm out of room, so I'm going to come up here, and that gives us 27 equals 9x squared. Divide both sides by 9. 3 equals x squared. And we're going to take the square root of both sides. Don't forget the what? You got it, the plus or minus. And that means that x equals plus or minus the square root of 3. And that's all.